Moving next, we are going to move to the vision transformer. I just want to remind you that we will put the link for participant certificate once we finish the workshop. So, vision transformer. Now, the transformer has been proposed for the natural language processing. So, what make us not use it in the images? These both different tasks, but there is implementation called vision transformer. This is the try to use a pure transformer as possible to the computer vision task and the work, showing that the transformer network has outperformed the convolutional neural network, and it is much more better in training and in performance. But what is doing that is the paper called an image is worth 16 by 16 word, and it is just that we dividing the image in batches. Let's see how this done. So if you look at this beautiful image that we have the image here, this image is being divided in batches, and these batches will be projected and flattened into a linear layer. And by this, we are doing the embedding. And then we are adding learnable class. So we understand the position. We wanted to understand the structural of the image. So this is for position learning, if you want to call it a positional encoding. Then we are going to go to a normal transformer encoder layer. And this is just ahead for classification. So this is simply the word embedding, and this the positional encoding, and this is the transformer. So this is the three method, dividing the image into grid of square batches. Then each batch is flattened into single vector, and then we are going to allow the model to learn the structure by adding this learnable term. Let's see. So firstly, dividing the image. Just a reshaping. So here, the code that if you want to define the main structure, batch size, color, channel, and this is must represent the height. So I want to say the height is H and BT1. And this is must represent the width. And I want to say this width is W and BT2. I know BT2 and I know BT1. So I want you, because this and this and this, I don't know it and I don't want to know it. This is just want you to change its shape to be batch size, given this, and taking the multiple of height and width, and it will take this W and this H, and the last size will be BT1 multiplied by BT2 and multiplied by color channel. So it will do the magic work. For example, if we have two images in batch, there is a 3 color channel, and this is RGB, and we have the height 128 for the height and similar for the width. So what will happen is that because we having the batches as 16, we are going to take is the multiplication of these, the color channel multiplied by 16 and 16, and this 8 and 8 is coming from division of this 128. Now this is going to give us this shape, 2 batches, the batch with the 2 images in 64 here and 768. Now this is just doing the batching and making this ready to work. Now in each batch is flattened in a single vector. How we embed it, we going to feed it into a linear layer. And this by just saying that the input is this, the last dimensionality, and the output it's whatever we want it to be, the embedding size. So by these steps, we are doing embedding similar to input embedding in the pure transformer. When we do it in natural language processing, we're doing word embedding. But when we do it in vision, we take in these 2 steps. Next, that we want to add the classification token, which is the learnable here. And we want to add the location is a normal random numbers. And this just like random numbers like a weight that will give some numbers to these features, and the model will going to learn by iteratively. And this we adding the position encoding. Just we tell us this is the first batch, the second batch, the third batch, and so on. By this, we completing the positional encoding. Now, this is the main part for vision transformer. And the other part is this transformer network, which we already studied. So we want to move to the workshop, but before this, we are going to implement more advanced than VIT. We're going to implement what we call the data efficient vision transformer, and which is proposed by Facebook. Let's just look briefly on it. This model, DEIT, is the training data efficient image transformer. This model has outperformed the vision transformer. So it is much more efficient. What it's doing and how it's doing it. The first thing that the vision transformer need very large data set to be pre-trained on. So let's say we want to train vision transformer on ImageNet. We firstly have to find data to train it on. Just let's say that we calculated 7 million images outside ImageNet and we train the model on it. Then we will fine tune it and train it on the ImageNet. And this is exhaustive task, and not all researchers have access to, and just the big researching labs have access to this kind of images. And this is a bottleneck for vision transformer. So what Facebook does, with this model, they use a model, a method called distillation, which is the method or strategy of teacher and student, where there is a model work as a teacher that trained on the data and get a good accuracy, and there is a student who tried to mimic the teacher output. Now there is some modification on this to work fine with the transformer. So the learning, the way that this work, the way that Facebook make this work by not pre-training on a large image set, data set, they train the vision transformer called DEIT on a pure ImageNet, but using teacher-student strategy. How they do it? They training a convolutional neural network on the ImageNet and making this as a teacher. So because we already know that convolutional neural network has gained a state-of-the-art result, it can learn better representation of the image, then this will be the teacher model. Then the student, which is our transformer, will have to object. The objective is that to learn the label data set from the convolutional model from the teacher, and learning the classification token, and this classification token will help the model to give better attention weight to the locations of the images, and could get a good result in image classification. And this is the way they work by doing the teacher and student strategy. So let's move to the workshop. Let's move to the final example, which we are going to open this notebook. It is using the PyTorch Lightning on a data set called Runzer Clip, Gather and Line Position Challenge. This is the notebook. I hope you open it, and we're going to see it and implement it. Just you have to see the data set, and this is the challenge. So this is a medical images, and this is a medical challenge. And this, let's just take the notebook and copy and edit it. So when you want to run this model, I will open it like this. Let's just give me a few seconds. Okay. While it's opening, that firstly that we're setting the environment. I put into you here that if you wanted to work on GPU or TPU, but if you wanted to work on TPU, some augmentation method not implemented good in the libraries, so or they are not they cannot work with the TPU, so the library shifted to the CPU. You will note some delay on the training with TPU, and this is not from this notebook. This is from the main PyTorch Lightning and the XLI library, so the accelerator library. So this just to let you know it. So I'm going to run it on a TPU, on the GPU. If you want to set this to TPU, it's up to you. I'm opening that in GPU mode. Now, this for TPU, if you want the PyTorch Lightning to work on TPU, you have to install the XLI library. If you run it, it will not work because I'm setting GPU here. The first thing that I'm going to uninstall PyTorch Lightning and uninstall TIMM, which is a library that have a mini pre-trained model for images. Now, this is the core part that is needed by PyTorch Lightning to work. So I separate it for you to make the work clear. Next, that is the normal libraries we are going to use. I'm setting randomly seeding to make sure that the experiment can take similar result whenever I rerun it. Now this is the configuration where is the train path, the test path, and also the profile of the notebook if we going to use TPU or GPU, what is the batch size, what is the epoch number, and which we are going to monitor. And reading the data train in the CSV, which is the location of the student UID, and this is the classes we are going to predict, and just splitting it into a train and validation using model selection. Now this is a normal class for data class. This is from data extending the data set from Torch. So what we are doing here is that we're building a class for data set that will going to read the images and the location and make sure if there is a transformation, we'll do it like augmentation, and also will output for us the label because it will read it from the data frame. And it's no, if it's training mode, then it will take the training path. If it is not, we'll take the test path. So it can work both in training and test. Now this just we setting the normalization using mean and standard deviation and doing some augmentation like random flipping both horizontal and vertical and resizing and cropping, and important part that we wanted to make it as a tensor so it can work on the GPU and work in Torch and taking the normalization for it. While in validation, we are just going to make sure the size as we define it and normalize it. We don't want to do augmentation and validation. Next is just I'm going to initialize the class in this names. I will move unused variables, deleting them, and then I will make my data loaders and make sure there is a shuffling true, and there is setting the number of workers, so distributing the worker to speeding up the reading process. While in validation, we don't want to turn on the shuffling because, you know, when you train, you want to give different batch ordering to the training model, so it's not some kind of biases or overfitting to the structure of what's giving in the data. While in validation, we want to take the same result of validation or equal judgment of validation of each epoch to the model, so we know if it's perform better or not. So we want it to be equal for each validation stage. Next, I'm going just to make sure that this part is working. So I will going to take one batch and see if it's returning a class to me. Just simple checking to make sure everything is working. Now, the next thing is that this is if you're not knowing PyTorch Lightning, this is the main class that you want to use for PyTorch Lightning SPL.Lightning model. You extend it, when you extend it, you can do the initializing here, and you will have a training step. You would do your training job here, and the validation step, doing the validation, and you can configure optimizers here. Let's just see what we are doing. Now, because we are going to use data efficient image transformer from Facebook, it is, if you want to use it separately, so just you calling torch.hub.load, and this is the name of the weight that you want to take. This is the main Git repo, and this is the weight or the model we're going to work with, and this is the batch size, and this is the image size. And we want it to be pre-trained, so it will download the weights. Next, we are going to do some fine tuning. So I am going to freeze the earlier layer and making require grad to false. So make sure it will not trained. It will freeze the weights. So no training here. While the next layers will be trained when I set it to true. I will just add a symbol, very simple network linear layer, which is will taking the output and will the input from this model, and will give us the output was at 11, which is the number of classes we are going to predict. So there is no hardened crafted engineering here, and I'm not improving the network here. I'm just show you the concept. Now the forward will basically forwarding the input to the model. But in the training step, what we are going to do is that we take in the batch that's given to us. It consists of X and Y, because we know from the previous, the dataset class, we will going to output to you, returning to you the image and the labels. So we're going to calculate X hat from inputting it to the model. And then we're going to calculate the loss using binary cross entropy with the logics, because here the model does not have a sigmoid. It will output the output from the linear without any non-linear activation function. Next, we are going to logging the training loss and returning the loss. For validation step, also, we are going to calculate the loss, and I'm doing some little stuff here. I want to calculate if we are going to get, we are going to save the model based on the loss. So the model that have a better loss will be saved. Configuring the optimizers, I set different optimizers to you. Maybe you want to make it reducing the learning rate based on the plateau state if the model does not learning anymore and there is no improvement. And also I set to you the cosine annealing learning rate and also cosine annealing with the warm restart. These are good. Learning rate scheduler, set it to you. You can use whatever you want by just changing which one you choose from here. So moving next, I'm just going to run this. And now I'm just initializing the class to getting the class model, and it will do download the weights for the model and compiling my script. Now this is just a callback functions that I want to do early stopping, and I want if it's in the GPU, so do this trainer, the minimum batch epoch and the maximum epoch, synthetic checking, and I will give it to make it know to use all the GPUs if available, if you're using TPU or CPU. So this to choose which profile of callback and which profile for training. Now just once this, we are going to do training.fit. So this will going to work with PyTorch Lightning, and we'll start to training. By this, I am ending my workshop, and this will go into working background, and I'm just going to stop sharing and see if to send you the link of the form, so you can get your participant certificate, and also we'll hear your questions. So next we are having the Q&A session. Thank you everyone for your patience and for listening to me.
Okay, thank you, Ma'moon, for what you share. It's very knowledgeable, and thank you for doing this for Iraq, and learned a lot from you today as always. السامعين إن شاء الله إحنا أيضا طبعا نشكر المأمون على مبادرته وعلى اللي يقدمه اليوم، وعلى بناء كوميونتي جديدة من ناحية الديب ليرنينج والباي اند اي اي للارتفيشال انتليجنس. راح افتح لكم الشات، اللي عنده السؤال يتفضل يسأل.
يعني وايضا اذا يحبون كمايك مو مشكله، يعني حسب
واللي يحب يسأل يعني يخلي يرفع ايديه، واخذكم واحد واحد حتى نسألكم. زين، ورابط الاستمارة هذا ايضا هم موجود حتى بالنسبه
اللي تسجلون بها هذه حتى تاخذون سيرتيفيكيشن للبارتيسيبنت بهذه الوركشوب. واذا احد بكم عنده سؤال ننتظركم، احنا موجودين.
خلينا نشوف. سيف عندنا اول واحد. افتح المايك سيف.
السلام عليكم.
السلام ورحمه الله.
طبعا البدايه عاشت ايدكم على السيشن اللي مفيده جدا. انا بصراحه عندي سؤالين. الاول على الترانسفورمر والان ال بي، اللي هو يعني for research purposes مرة يعني تجربها، انه احنا نعرف السايز هو 512 ماكسيموم للبيرت، بس ما ادري اذا ردنا ندرب، اذا ردنا نغير بيه ونسوي مثلا اكثر من 512 لازم نعيد تدريب الموديل كامل، لو نقدر بس الفاين تيونينج الاخير كافي اذا اردت اغير بالاركيتكتشر يعني مال بيرت نفسه. هذا اول شيء. والسؤال الثاني على الفيجن ترانسفورمر. انا ما اعرف يعني مثلا الدايت، بالنسبه اللي هو يمكن دايت اسمه من فيسبوك، بالنسبه للدايت يعني مقارنه باليولو او الار سي ان ان اللي هي البري ترين موديل اللي مبنيه على اللي مبنيه بال يعني على بيست اون سي ان ان، يعني شو تشوف انه افضل؟ يعني الدايت اللي هو مبني على الترانسفورمر افضل من اليولو والار سي ان ان، لو يعني شنو؟
تمام. اوكي، عاشت ايدك. تسلم.
تسلم.
حبيبي انت. اولا بالنسبه للبيرد، فانت هو التاسك اللي حتسويه انه انت اكستند على الاركيتكت مالته. فانت اذا كلاسيفيكيشن مثل اللي انا سويته، انا ضفت لاير. واذا عندك بالنسبه لل 512 او غيرها، هذه الامبندنج مالت الوورد بالنسبه للانبوت، انت اذا تريد الاركيتكت مالت شلون نقول الداتا اللي عندك اذا تحكي بال 512 از اوتبوت او از انبوت. اذا از انبوت اي كمل اسمع.
اي قصدي كانبوت، يعني اذا
كانبوت كانبوت هذه هو انت بالحقيقه تقدر تسوي لينير لاير اخرى او تغير بيها من الانبوت اللي طاب، او هو نفسيته البرت نفسيته. الغايه من عنده انه انت هسه شفت انا ما سويت اي وورد امبندنج، ما سويت لا رحت استخدمت جلوف ولا وورد تو فيكت، هو شغلته حيطلع لي وورد امبندنج. فانا فهو راح ياخذ البيست ريبرزنتيشن، فانا ما اخذ منه الريبرزنتيشن وراها اسوي التاسك اللي عندي. بس اذا هو مثلا ما مدرب على اللغه اللي عندي او على تاسك قريب، مع العلم اشك انه ماكو، لان صارت هوايه اكستندد عليه، شيل العربي شيل تويتر شيل غيره، فهو تخيله از وورد تو فيك، تخيله از جلوف، بس حيخلي لك ريبرزنتيشن. انت اكستند لللايرز اللي بعده. يعني انا ضفت لاير للكلاسيفيكيشن فقط، خلص انا عندي سنتمنت اناليسيس. انا طبعا ما سويت اي بري بروسيسنج، لا اكو ستيمينج، لا اكو كوركشن للمس سبيلنج، لا مجرد اخذت الريبرزنتيشن مالته فدت تو اي لينير لاير واشتغلت الامور. طبعا هذه من حتى تاخذها تران تجيب لك 82% كاكيورسي، ممكن تجيب اعلى اذا زيدت البري بروسيسنج. فانت اما انه تغير على الاركيتكت وتدرب بيرت، فالموضوع مو سهل. ليش؟ لنقطتين. الاولى يراد لك ديتا مو اعتياديه، عدد ديتا كبير. الثانيه يراد لك هاردوير مو طبيعي، يعني هذا حتى تصرف عليه يعني ماذا تطلع به بالكلاود. اذا انت تجوز باليوم جزء تصرف لك بال$10,000 على عدد الكلاستر اللي حتبنيه، لانه مكلفه. فهو الفكره من عنده انه هو بري ترين جاهز لك، هو باوزانه فاين تيون فقط. انت وين حتسوي فريز باللايرز مالته او تريد الدربه كله، وفقط اكستند لللاير اللي فوقها. وهو دائما بالبيبر منطيك شغلتين، اما مودي الموضوع الريجريشن والجنريتنج للوورد مثل باوتري جنريتنج او غيرها، ممكن تتحكم بالاوتبوت مال اللينير لاير اللي انت ضايفه. هذه بالنسبه للان ال بي تاسك.
بالضبط. عاشتك. هو انا كنت نقاش ويا ولد صديقي، فيعني وصلنا انه انت ما تقدر تعيد تدريب البيرت من جديد، لانه راح ياخذ ريسورس وراح ياخذ تايم.
والله هو لو اكو عندنا مثلا من احد جامعاتنا انه تبني لاب يحتوي على الهاردوير المطلوب، ممكن تسوي هيك اعمال، لانه هواي اكو شغل بهالمجال. خاصه احنا مثلا اللانجوج مالتنا او اللهجه مالتنا وغيرها، بس اللابات ما موجوده وكانت ممكن تشتري. بس هسه من غلت اسعار الجي بي يو شوي الموضوع صار غالي كلش. كنت ممكن تجهز من السوق وتسوي كلاستر، بس هسه الكلاستر هواي يكلفك، فيعني ما عنده غير الفاين تيونينج. يعني هو الكل ترى تشتغل فاين تيونينج.
اي لا اكيد اذا اكو فاين تيونينج موديل هو يعني ليش بعد واحد يستعمل
اعتقد عندنا اسئله ثانيه اذا سيف.
تمام بس اكمل اجاوب السؤال الاخ. اوكي. بالنسبه للدي اي تي هي هذه للكلاسيفيكيشن بس. فيسبوك طلعت ديت، او اغلب الشغل صار تحول نفسها اليولو يضيفون عليها اتنشن نفسها البقيه، او تنقلب كليتها بدون اتنشن، تنقلب كلها ترانسفورمر. الترانسفورمر اوت برفورم كل الكونفولوشنال نورال نتورك اللي موجوده سواء بالكلاسيفيكيشن او جماعه الاوبجكت ديتكشن، يعني اليولو، الريتينا نت، الماسك ار سي ان ان غيرها. اكو مكتبه عند فيسبوك اسمها ديت وليس دي اي تي. هذه تعتمد على الديتكشن باي اتنشن ميكانيزم.
فهمتك. عاشت ايدك ممنونين.
شكرا لك سيف. شكرا مأمون. اذا احد عنده سؤال بالشات او يرفع ايديه حتى نجاوب على السؤال. اعتقد ما عندنا اي احد يسال. انا هنا اللي ورا بالانستغرام بالتليجرام ماكو اي اسئله عندي. عندنا طبعا حضور كان من بريطانيا، كان مصطفى موجود من احد الجامعات البريطانيه موجوده، كان ويانا محمد علي برودكت مانجمنت من طلع الاجتماع مالته ويانا، كان محمد اسماعيل من تويوتا اللي على السيلف اوتوميشن. عندنا حضور جدا ممتاز. او هذا محمد اسماعيل بعده موجود. والله هواي ناس اليوم ما شاء الله، كان حضور جدا ممتاز. اعتقد ما عندنا اسئله بعد مأمون. زين عاشت ايدك. بالنسبه للسامعين احنا باكر راح يكون عندنا ال ام اس ثانيه نفسي مال اي دبليو اس العراق اللي هو الليرنينج مانجمنت سيستم بالكلاود. راح اكون ويا جامعه تكريت ساعه بال8 بالليل بتوقيت العراق، فاذا تحبون تحضرون احط المعلومات على الفيسبوك وعلى الميت اب مالتنا، وان شاء الله ان لقاءات قريبه اكثر بعد.
ان شاء الله.
وشكرا مأمون على جهودك اللي تسويها، وان شاء الله احنا لنا لقاءات
انه اكو حيجيهم ايميل او اذا اوريدي انداز اوتوميتد ايميل راح يخص كوبون ل 50% خصم على كورسات deeplearning.ai. بس سيرفي بسيطه تجاوبوها عن الورشه وانطباعكم العام، حيوصلكم ايميل. وبالنسبه لرابط السيرتيفيكيت مالت الحضور فهذه هو موجود يمكن بالشات مالت الزوم، يعني اذا تحبون املوها وحتوصلكم السيرتيفيكيت ايضا على ايميلاتكم اوتوماتيكلي اول ما تمليها، يعني شغله دقيقتين توصلك سيرتيفيكيت الحضور. واشكر حضوركم جميعا، يعني شرفتوني وان شاء الله استفاديتوا بشيء ولو بسيط من الورشه.
شكرا لك مأمون وشكرا للحضور، وان شاء الله ان لقاء. احنا الاسبوع الجاي عندنا كاغل ان شاء الله السبت الجاي.
ان شاء الله السبت القادم عندنا كاغل ميتاب عراق، واللي حتقدمه يعني كاغل جراند ماستر من الهند ايضا في مجال الميديكال ايمج كلاسيفيكيشن.
ان شاء الله. يلا شكرا لك وتصبحون على خير. بالنسبه لكم احنا بعد عندنا 12:30 الظهر هسه.
اهلا وسهلا. مع السلامه.